Welcome back to my YouTube channel. Today we're going to be going over to 13. So we have PHY 100 tutorial sheet 13. So we start with question 1. So question 1 is, an object of mass m is hung from a spring and set into oscillation. The period of the oscillation is measured and recorded as t. The object of mass m is removed and replaced with an object of mass 2m. When the object is set into oscillation, what is the period of the motion? So now, in this question, we can draw a free body diagram. And by the way, it's not necessary in this question to draw, but then you can just draw to show your way through. So we're going to have the first one. You have the mass m. We have the spring constant K. Then we're going to have the second one. Same spring, but now the mass is doubled. We have got 2m. Then we have got K. Then we have got our 2m there. So now we're being told this mass is removed and then replaced with something like this. So now we're being told how does the period change? So now we know that the period is given by the formula T is equal to 2 pi square root of m over k. So now, here we are going to have two situations. So I've got the first situation. So I've got situation 1 and situation 2. So in situation 1, our 2 pi is a constant, but then m, here we have got m1, and then here I've got m2, which is equal to 2m1. Meaning that m2, this is m1, this one is m1, and then this one is m2. And then we have got our k1, then here I've got k2, and then k1 is equal to k2, and then I've got t1, then I've got t2. So we want to see the relationship between t1 and t2. So what we're going to do is we're going to write the formula. So t1 is equal to 2 pi square root of m1 over k1. Then t2 is equal to 2 pi square root of m2 over k2. Then now we're going to make the replacements here in relation to the ones that are in mt1. So we are being told to say m2 is equal to 2m1. Meaning here where there is m2, you can replace it with 2m1. And then k2 is just equal to k1 because the spring is not changing, which means the spring constant is actually still the same. So here what we can do is we can make these replacements there. So then we're going to have t2 being equal to 2 pi square root of 2m1 over k1. I think I can rub this part. I can rub this part. So that we continue with our formulation. So now, what we're going to do is we're going to relate this one to this equation. This equation here to this one. So that we can relate T1 to T2. So what we're going to do is now, T2 is going to be, we're going to remove these 2 out of the square root because this 2 is actually not here. M1 is here, K1 is here, and 2 pi is there. So I'm going to say, according to the laws of indices, when you have got A, B over, let's say, C, this is going to be equal to, this can be equal to, you can have the square root on A, square root on B over the square root on C. So there what we can do is, we're going to remove this square root, we're going to have 2 pi square root of 2 square root of m1 over k1. So now when we put the 2 the other side, we're going to realize that this, what we're going to remain with is just t1. What I'm trying to say is t2 is equal to square root of 2, then 2 pi square root of m1 over k1. So now, when you look at this is just equal to t1. So what we're going to do is t2 is equal to the square root of 2. Then what is this? We're going to replace it with t1 because this is actually equal to t1. T1. And that's our answer. we have expressed T2 in terms of T1. So in the question, it told us to see how the period changes. So the period changes by factor of 2 pi, or square root of 2, sorry. So that's the end of this tutorial. Remember to subscribe to the channel, like the video, and also if you have any other questions, you can send them to 0978957975, or you can send them to my email, which is davidcbanda237@gmail.com. That's all for me. Bye bye.